Okay, good day. So this is our last topic for General Physics 2, which is electric flux and Gauss law. So our learning competencies to be discussed for this period are first calculate electric flux, and then second is to use Gauss law to infer electric field due to uniformly distributed charges on wires, spheres, and large plates. Okay, but before we proceed with our main topic, let us recall what's we have learned on our previous discussion. Okay, so um, regarding electric field lines, okay, as we know, electric field is the space around an electric charge. So electric field lines may differ depending on what is our point charge is. For positive charge, okay, the electric field line is directed outward, the point charge. On the other hand, if negative naman yung point charge natin, yung electric field line is directed towards the point charge, okay? So when these charges interact, okay, with one another, okay, so they create this representation of attraction. When two opposite charges move closer to one another, they attract. And when we have two like charges, they repel each other. Okay? So this is through the calculations of the electric field magnitude using the equation E is equals to force per given value of test charge. Okay? So based deriving another equation for electric field from Coulomb's law, we have another equation which is E is equals to K multiplied by the value of our point charge over the distance squared. Okay? So now, let's move to our main topic, which is electric flux. Okay? As we all know, each charge particle, okay, distributed its lines or it distributed its force due to or with the use of electric field lines. Okay, so this, okay, for example, we have a hollow box, okay, and we put an individual charge or a single charge inside a hollow box, and then on the second diagram we have the same hollow box, same size, but we tended to put the two charges inside it. Okay, as we can see on the right part of our diagram, okay, so makikita natin kung gaano kadaming field lines, okay, yung um, ini-exert, okay, ng isang individual charges. Okay, so pag dami ng charges nakapaloob sa isang surface, okay, so ganun din yung dami ng magnitude na na-exert niya. Okay, this term or this phenomenon is what we call electric flux. Okay, it is the change or it is the rate of a flow of electric field through a given surface. Okay, so yung pag-spread out ng ating electric field, okay, illustrated by lines here in our diagram, is what we call the electric flux. So electric flux, we defined it as the electric field through a surface. Okay, given the equation phi, okay, phi is the denotation of electric flux is equals to the dot product of electric field and the surface area, okay, the surface area vector of that specific object, okay, and then given to expand this dot product of two vectors, electric flux phi is equal to the electric field multiplied by the area vector or surface area cosine theta. The theta here is the angle between our electric field and our area vector. vector. Okay, in some notes or in some books, this area vector can be denoted as the normal vector. Kasi si area vector is always perpendicular to the surface of our object. Okay, can be a box, a balloon, or a cylindrical surface. Okay, so the unit used for electric flux is equal to Newton meter squared per coulomb. Okay? So it is denoted by a Greek letter phi. Okay? So the electric flux can be calculated in different orientations. Okay? Let us focus on this first orientation. Calculate the flux of the electric field E, okay, given this E, through the surface area A. Okay, this is our surface area in each of these three cases shown. So this is the first case. Okay, so the area vector here, as we know, okay, it can be the normal vector and can be the area vector. It is always perpendicular with our surface. So the direction of our area vector is towards this direction. Okay, the electric field vector, the direction of it, kasi ganyan yung orientation ng ating surface. So papunta rin siya dito. So makikita natin the angle between, okay, the angle between our electric field vector and our area vector is equals to 0. Okay? Kasi pareho silang nasa x-axis. So 0 degree. If we would be applying the equation for electric flux, phi is equals to EA cosine theta. Okay? So yung value ng E, value ng A, cosine 0 degree. Cosine 0 degree is equals to 1. So the value on this kind of orientation of our electric flux is cosine 0 is 1 is at the maximum. So we have to multiply the magnitude of the electric field to our surface area vector. Okay? Since cosine 0 is equals to 1, so most probably in this kind of orientation, the magnitude of our electric flux would be at the maximum. Okay, this let's move forward with our second type of orientation. So comparing from our first diagram, so makikita natin yung plate natin dito. Yan, nandito na siya sa direction na to. Okay? So, same again, i-calculate natin ulit yung most probably value of our electric flux by analyzing this kind of orientation. But first, alamin muna natin yung direction of our area vector. So, yung area vector, again, parallel with our surface. So, papunta dito, yung kanyang direction. Okay? Our field vector, or yes, our field vector is going through the part, this part. So, this is the direction of our electric field. So, ano yung angle na mabubuo natin? Okay, angle theta. Okay, angle between electric field vector and area vector. So what is supposedly the direction between them? So it is, so kung ipo-plot natin dito yung ating electric field vector, so ang layo nila sa isa't isa would be 90 degrees. Okay? So applying the equation for electric flux, EA, cosine theta. So our theta, we would be using 90 degrees. Cosine 90 degrees is equals to -1. Okay. Cosine 90 degrees is equals to 0. Tama ba? Cosine 90. Yes. Cosine 90 is equals to 0. So the calculated electric flux for this kind of orientation is equals to 0. EA multiplied by 0. Okay. So if we have this kind of diagram where our surface is perpendicular with our field, or though there is no field um, passing through, okay, a specific surface, so most probably the amount of electric flux, okay, on that surface would be equals to 0. Kasi what is our definition of electric flux? It is the flow of electric field that penetrates a surface. Okay? And then last, this orientation. Okay? So we have here our third orientation where our surface is slightly slanted. Okay? In comparison with our first diagram. So calculate the electric flux of the electric field E through a surface A, and in each of the three cases, show. Okay? So, makikita natin yung ating electric, this is our electric field vector, the first line here. And this is the perpendicular line to the surface is our um, area vector. So most probably, the distance or the angle between them is less than 90 degrees. Okay? So kung i-compute natin based from our equation, EA cosine less than 90 degrees, okay, it would have a value of um, uh, at the middle. For example, kung ang value ng ating theta here is 60, okay, 60 degrees, EA cosine 60, okay, cosine 60 is 1/2. So, our value would be EA, okay, times 1/2. So, kapag 60 yung angle niya, EA over 2. Okay? So, ganun po yung pag ganito yung orientation. So, what if naman angle, okay? What if our angle theta is greater than 90 degrees? So, kapag greater than 90 degrees, cosine greater than 90 degrees is equal to negative. So, lahat ng i-cosine mo na mas malaki sa 90, ang magiging value mo dyan is a negative magnitude. So, most probably, if negative yung electric flux natin, okay, if negative ang electric flux natin, the electric field, the E field is coming from, okay, coming from the outside to inside. So what does this mean? Okay, meaning yung electric field na nararamdaman ng surface na yon, hindi siya galing dun sa loob, okay, ng material mo. Galing siya dun sa labas ng material mo. Na-experience siya from an outside factor. Kapag ganun yung nangyayari dun sa situation mo, the E field or the electric flux is negative. Okay? Positive naman ang electric flux mo kapag ang E field mo or electric field is coming from, vice versa, coming from the inside to outside. So meaning, yung electric field na na-experience mo ay galing sa loob palabas. Okay? So, now, i-summarize natin yung orientations of electric flux. First, kapag ka cosine may zero, meaning the electric field vector and the area vector is at the same direction. Okay? The angle between them is 0. Okay? Cosine 0 degrees is equals to 1. So the value of the electric flux is at the maximum. Okay? So, dito naman, kapag cosine 90, okay? Kapag cosine 90, okay, your EA, your electric field, and area vector are perpendicular with one another, perpendicular, okay? The angle between them is 90 degrees. Cosine 90 is equals to 0. So, meaning the value of our electric flux is equals to 0. Meaning there is no field vector that penetrates a surface. And then lastly, if we have a value of, or the angle between EA, electric field vector, and area vector is less than 90. So, yung magiging value niya is a positive flux. Okay, flux density is positive, meaning it comes from inside to outside. On the other hand, okay, lagyan natin dito. On the other hand, if we have an angle greater than, okay, greater than 90 degrees, electric flux, the value of it would be negative, okay? So, the field line comes from outside to inside. Okay? So that is how we calculate electric flux depending of the orientation of our surface. Okay? So what if our surface is curved, or the field varies with position? So paano kung nagbabago daw yung electric field natin, depende kung saang posisyon siya sa isang curved surface. Okay, based from our discussion, we know that electric flux is equals to the dot product of electric field vector and area vector. So, para makuha natin, okay, yung total electric flux on a varying position, we have to divide the surface area into small regions. So, kukuha lang tayo ng isang part doon sa ating surface, okay, nakukuhanan po natin ng um, differential of our area, or in terms dA. Okay? So, the flux through that small part that we get into the region of a surface is equal to using that differential area, we can calculate the flux, d flux, okay, or d phi is equals to E, the electric field vector, multiplied by the differential of an area, cosine theta. Or, electric flux, differential of electric flux is equals to E, dot product of dA. Okay? So, to obtain the total flux density, we need to integrate over the surface area. Okay? In terms of phi. So, since we are getting phi, integrate both sides, okay? D phi is equals to integrations of E, dot product of dA. So, this is how we get Okay? The value of the flux density if we have a varying field or position of a field in terms of a curved surface. Kasi kanina, flat yung surface natin. So, direct algebra lang. So, dito kasi varying siya. So, we need to get a small part of that surface and then integrate it for us to get the total flux density. Okay? This is for open spaces or open surfaces. What do we mean by open surfaces? For example, we have a cup or we have a coffee mug. Okay? So, makikita mo doon yung amount ng um, kape na nasa loob ng mug by merely uh, looking at it. And you can also see the smoke coming out from a hot coffee. Okay, that is an open area. So or open surface. Kasi nakakalabas yung mga particles from created by the coffee. Okay? As it evaporates. Okay? So ang isa pang surface is what we call the closed surface. Okay, dito para siyang lata. Okay, lata ng corned beef na hindi mo pa nabubuksan. Okay, so hindi mo makikita yung itsura ng corned beef by just looking on the bottom part, on the top part, on the side part. So, hindi makita ng itsura ng corned beef kung nag konti lang ba yung sabaw ng corned beef or what. So, ang tawag dun sa enclosure na yun is a closed surface. Okay? So, this closed surface is also called as the Gaussian surface. This is symmetrical. Okay? Meaning, all of the parts of this surface is or do have the same sizes. Okay? So, nagpo-form ng symmetry yung Gaussian surface. On a closed surface, the flux is considered to be positive for filled lines that leave the enclosed volume. So, kapag ka ang filled lines po natin, again, same as the open surfaces, is coming from the inside to the outside, our flux density is positive. Our flux density is negative if the filled lines natin is entering, is entering our enclosed volume, or um, the flux or the field magnitude is coming from the outside to inside. Okay? So, same lang yung equation na gagamitin natin for open surfaces and closed surfaces or Gaussian surfaces. We just need to indicate this symbol, okay? So sa integration natin, kailangan lang ng gantong symbol to represent that we are getting, okay, the flux density, okay? The electric flux density. Tandaan ha, electric flux kasi meron din tayong magnetic flux, okay? So the flux density on a closed surface, okay? Now, nabanggit natin yung Gaussian surface. Okay, this Gaussian surface is derived from Gauss law or Gauss law. So this law states that this law is an expression of the general relationship between net electric flux through a closed surface and the charge enclosed by the surface. Okay, so para mas madali nating maintindihan, let's take a look on this diagram. So meron tayong sphere, okay? This is example of a Gaussian surface. Closed po siya. May para siyang globe. Yan. Okay? So, sa gitna ng sphere natin, meron tayong, at the middle part of it, meron tayong isang charge. Okay? Positive test charge on this case. Okay? R here is the distance or the radius with respect of on the middle of the sphere. So, yun yung radius niya. And sabi po natin, yung electric field daw niya, Okay? Since nasa gitna siya, papunta dito sa direction na to. Tapos, if we are getting the part of this region, yan, kung kukunin natin yung part ng region na to, so yung ating dA or this area vector would be perpendicularly or radially uh, coming from the middle outward, perpendicular to the surface, it has the same direction as our electric field vector. So, dA is always parallel if we are talking about symmetrical closed surfaces according to Gauss law. Our differential of the area vector is parallel to our electric field vector at any point of our sphere. Okay? So the angle between them, angle theta, between them is equals to 0. Kasi pareho sila, parallel sila. Pareho sila ng direction. Okay? So if we are going to use that with our equation of electric flux phi, so EA cosine theta, since dA is parallel to E, so EA electric flux phi, EA cosine theta or cosine 0 is equals to 1. So phi is equals to EA. Okay? So, since our Gaussian surface here is a sphere, in order for us to get the surface area of a sphere, we use this equation. Area of sphere is equals to 4 pi, okay, r squared. So, pwede po natin siyang isubstitute dito sa ating equation ng electric flux, E 4 pi r squared. Tapos, si electric field vector from our previous discussion is equals to Coulomb's constant multiplied by the magnitude of a point charge over r squared. Okay? So, pwede natin siyang isubstitute ulit dito. Okay? K, Q, okay, 4 pi r squared all over r squared. As we all know, Coulomb's constant is equals to 1 over 4 pi, okay, epsilon naught. Okay? So, kung isa-substitute ulit natin yan, so, Q 4 pi r squared over 4 pi epsilon naught, okay, r squared. So, meron na tayong may ka-cancel. So, you cancel out 4 pi, cancel out r squared. So, malilive na lang po tayo ng equation of electric flux, okay, which is Q over epsilon naught. Okay, what is epsilon naught? Epsilon naught is what we call as the permittivity of free space. So it is also equal to the value of 8.85. So this is a constant value, 8.85 times 10 raised to negative 12 Newton meter squared. Okay? So, if we have, that is for a single charge, okay? Using Gauss law, calculating electric flux density on a Gaussian surface or at a closed surface with a single charge, we use this, okay? we use this equation. So what if madagdagan, okay? Madagdagan yung mga charge natin, pero attached pa rin siya doon sa middle part ng ating Gaussian surface. So, based from our equation, phi is equals to Q over epsilon naught. So, we have to find the summation or the value of all charges that can be found on an enclosed system. So, our equation would be phi is equals to summation of the charges in an enclosed surface all over epsilon naught. Okay? So, that is how we get the value of the flux density with more charges on a closed surface, or the total electric flux. So in summary, Gauss law can be mathematically defined using this equation. Phi is equals to summation of Q on an enclosed system or total magnitude of charges in a Gaussian surfaces over or divided by the permittivity of free space, which is equals to 8.85 times 10 raised to 12 negative 12 Newton meter squared. Okay? So, as we define Gauss law, this law, according to Friedrich Gauss, this law is or states that the electric flux going through a closed surface is the sum of all charges inside the closed surface divided by the permittivity of free space. Okay? So, when we are going to calculate the total magnitude of or the total density of electric flux going or that penetrates a Gaussian surface, which is also known as closed surface, we need to find the summation of all charges and divide it with the value of permittivity of free space. Okay? So, that is all for this lecture. Before I ended up my discussion, let me share this quote to you. This question, what is a soul? Okay? It is like an electricity. We don't really know what it is, but it is a force that can light up a room, according to Ray Charles. Okay, so that would be all for this lecture. I hope you have learned something from electrostatics. Okay, so we have learned electric forces, electric field, and now electric flux and Gauss law.